Hey guys! So last time we talked about how as we go across the periodic table, atoms' cravings for electrons grows at an exponential rate. But there's one more part of electronegativity that we need to talk about. As you've probably heard the phrase, opposites attract, it applies directly here. So protons and protons are going to repel each other. Likewise, electrons and electrons will repel each other, but protons and electrons will actually attract one another. So, knowing this, let's take a look at the elements fluorine and iodine. This is a fluorine atom, and in the middle right here, this entire green circle is the nucleus. So, as we can see, fluorine's valence shell is only one shell away from the nucleus, meaning that there's only one electron shell between the valence shell and the nucleus. So, that means that the electrons in this outer valence shell can really feel the pull of the protons in the nucleus. So, this makes fluorine really want to gain an electron. Now, let's take a look at iodine. Do you see how many shells iodine has? That's super insane. So all of these electrons that you see here in the middle are actually repelling these outer electrons right here. They're pushing them further away from the nucleus. So that means these electrons don't feel the pull of the nucleus as much as fluorine's would because these electrons are so far away from the nucleus. Now we call this phenomenon shielding, and that's because of all of these electrons in the middle right here, they are shielding the force that the valence electrons would feel from the nucleus, from the protons of this atom. And so, if iodine were to get another electron, yes, it would be happy, it would be satisfied, but it can't feel that satisfaction because it can't feel that extra electron to the same degree that fluorine has because iodine has so much shielding. So it would have a very small impact compared to the impact that fluorine would feel. And so what we realize is as you go down the periodic table, electronegativity actually decreases because there are so many more electrons, so many more electron shells. So therefore the valence shell is shielded from the force of the nucleus. So that means as we go up the periodic table and to the right, fluorine is going to be our most electronegative element because it really wants that last electron, and there isn't that much shielding from the inner electron shells, so then the valence shells can really feel the pull of the nucleus, of the protons in the nucleus. So, knowing that, let's get started on some problems.